So here's page 307, number 9 and number 11. Okay, so number 9 says if 2x minus 3y equals a, x, y, and a are vectors, and negative x plus 5y equals 6b, express vector x and vector y in terms of vector a and vector b. So here's how I've done it. Okay. So I start off with 2x plus 3y equals a, and negative x plus 5y equals 6b. I write them down as I would for doing elimination in solving algebraic linear equations. So an intersection point of two lines. Okay, so a and b are the ones that you need to find x and y in terms of. So what I'm going to do here is try to eliminate one of them. If I multiply equation 2 by 2, then I add the two equations, I will have eliminated the x variable. So if I do that, okay, then I'll get this equation. So multiplying equation 2 by 2 and then adding them, x vector will go away. I will then get 13y equals a plus 12b. Divide both sides by 13 and I get y equal to 1/13 of a plus 12b. Doing the same thing with the eliminating the y, I'm going to multiply equation 1 by 5 and equation 2 by 3. That way the coefficients of the y's will be 15. And I'll be able to eliminate them. Actually, I'm going to multiply equation 2 by negative 3. Okay, so when I do that, here are the new equations that I get. When I add those equations, I get 13x equals 5a minus 18b. Then dividing both sides by 13, here's vector x in terms of a and b. And that's number 9. Number 11. Number 11 deals with this cube. A cube is constructed from three vectors a, b, and c as shown below. So a is from point A to point B, b is from point A to D, c is from point A to E. So creating a cube. The cube is all equal sides, equal size edges. Express each of the diagonals AG, BH, CE, and DF in terms of A, B, and C. Okay, so that should be fairly straightforward. In B, it asks to show that AG equals BH and explain. So really, AG equals BH. AG is a diagonal from point A to the opposite vertex in the cube. And BH is a diagonal from B to the opposite vertex in the cube from B, which is there. They will cross each other, and they want you to show that they're the same length. Okay? So here's how I've done it. So AG is equal to A plus B plus C in terms of vector addition. Okay, I can break that into A plus B, put brackets around there, plus C. Now I have two vectors. A plus B in this diagram, A plus B, is this diagonal across the bottom face. That diagonal is perpendicular to vector C. Okay, so if it's a cube, any vector on the bottom face is going to be perpendicular to the height of the cube, which is vector C. Okay, so if I can find the length of AB and then use Pythagorean Theorem with that length and vector C, I can find the length of AG, because AG is the hypotenuse of the triangle with AB as one edge, and vector c as the other. Okay, and in order to do that, well, I need to find the length of AB. Well, A plus B. A plus B is the hypotenuse of the triangle with edges A and B, and so we should be able to use Pythagorean theorem for that. Okay. So Pythagorean theorem basically says that the magnitude of A plus B squared equals A squared plus B squared, magnitude of each of those. So we've got this. Right. But before we get to that, let's write the formula for AG. So AG is the magnitude of A plus B all squared plus the magnitude of C squared. That's Pythagorean theorem. So AG is the hypotenuse, A plus B is the bottom side of the right triangle, and C is the other side of the right triangle. It's 90 degrees in between A plus B and C. Now replacing A plus B squared, the magnitude, with this expression, A squared plus B squared, we end up with basically a three-dimensional Pythagorean theorem. So AG squared equals A squared plus B squared plus C squared. Okay. Now we want to look at BH, which is the other diagonal we were talking about. Well, if we look at the original diagram, BH equals negative A plus B plus C. Okay, so this was B, and this is H. Okay, so negative A plus B plus C. Now, breaking this whole thing down similarly, we end up with this formula here. Okay, so negative A plus B plus C. Similarly, the magnitude of BH squared equals negative A squared plus B squared plus C squared. We know that negative A is the same length as A. So we can rewrite this as A squared plus B squared plus C squared, all magnitudes. That is the same as the formula we have for AG squared. So therefore, BH squared equals AG squared, and BH magnitude equals the magnitude of AG.